Hello, today we're doing 8.2, exponent properties involving quotient. Remember, quotient is a fancy word for division. So we have the same strategies as we had before. We're just taking it one step further. So I'm going to actually write this all out for the first few like I did the past couple days, and then I'll teach you the shorter way how to do it. So first, if we write this out as one big fraction, this is 8 multiplied 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 8 10 times. And in the bottom we have 8 4 times. 1, 2, 3, 4. So we know if we have a fraction like 8 over 8, 8 divided by 8 is just 1. So they really eliminate and make 1. So this is really 1 times 1 times 1 times 1, which is just 1. And then we have all of these 8s left over on the top. So we really have 1, 2, 3, 4, 5, 6 8s left over. We have 8 to the power of 6. And it's all times 1. There's really a 1 on the bottom, but if we divide by 1 or multiply by 1, it really doesn't do anything to our fraction. So our answer is really 8 to the power of 6. If we had taken just our exponents, 10 and 4, we could subtract 10 minus 4 gives us 6, our exponent. Our base 8 is still the same. Let's take a look at the second one. We have negative 3 5 times. So on the top of our fraction we have negative 3, negative 3, negative 3, negative 3, and one more, negative 3. On the bottom we have negative 3 3 times. 1, whoa, 1, 2, 3. And just like our 8s, negative 3 divided by negative 3, if it's all multiplication and division, we can simplify. That makes 1 times 1 times 1. And we have negative 3 multiplied 2 times. Leave it like this. You could put a 1 on the bottom if you want, but you don't have to. Same thing, we could have taken our exponents, 5 and 3. 5 minus 3 is 2. And there we go. Alright, next we have multiple 5s on the top. If you want to combine these, add your exponents. 8 plus 4 is 12. So we have 5 to the power of 12 and 5 to the power of 7. If you want, you can write it all out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 5s that are all multiplied. You don't really need the dot, but they're there. And then 7 5s in the bottom. 1, 2, 3, 4, 5, 6, 7. So most of them eliminate. 1, 2, 3, 4, 5, 6, 7 of them will eliminate. We know these ones are going to go away because there's at least 7 on the top. So how many are left over? There are 1, 2, 3, 4, 5 5s. Same with our exponents. 12 and 7. 12 minus 7 is 5. This next one looks a little bit different. Since one of them is a fraction, we can make them both fractions if you divide by 1. So on the top of our fraction, if we multiply, this is all really multiplication, 1 times x to the 6th is just x to the 6th. On the bottom, 8 to the 4th times 1, x to the 4th times 1 is just x to the 4th. So this is really x 6 times, and this is x 4 times. But you know 4 of them are going to cancel out, so we're only left with x squared. 6 minus 4 equals 2. There is one case where this is going to be a little bit different, and we will get to that on this one right here. So be careful when we get there. But we're going to now combine a couple skills we've learned. We know that if we have an exponent, that's really how many times we're multiplying or writing out whatever's in our parentheses. So we could write negative 5 over y. I'm just putting the negative at the top. 3 times negative 5 over y, negative 5 over y. And we could simplify, well, how many negative 5s do we have? We have 3. And on the bottom, we multiplied y 3 times. You also know that if we have our exponent, this is really a 1, and you're really multiplying our exponents. 3 times 1 is 3. And here, this is to the power of 1. 3 times 1 is 3. And we have our parentheses here. We multiply. So this next one is the same thing. We have negative 7 over x 2 times. Negative 7 over x. So we know we have negative 7 two times, and we have x 2 times. If you want to multiply it out, negative 7 times negative 7 is a positive 49 over x squared. That works too. Oops, I'm struggling today. But we also know that our exponent really just goes to both parts of our fraction, just like we had both parts of our parentheses earlier. Next, we could write this, whatever's in parentheses, 2 times a over b times a over b. You know there's 2 a's and 2 b's. The exponent gets delivered or distributed to both parts of our fraction. So this next one's a little bit different. If we make it a fraction like we did earlier, on the top we have 1 times 7 squared is 7 squared. On the bottom, 7 to the third times 1 is 7 to the third. So if we write this one out, we only have 7 2 times on the top and 3 times on the bottom. Oops, times 7. So when we cancel out some of our 7's, we only have 1 left over, and it's on the bottom. So you do need to include the 1 on the top. We have 1 over 7. Oops, our answer is 1 over 7. Slide this over a little bit. If we had more than 1 7 left on the bottom, we would write like 1 over 7 squared or 1 over 7 to the power of 3 or something like that. So we really did still subtract, but there was more on the bottom, so that's why our 7 is on the bottom. All right, this one's like the previous couple. This one, if you want to just distribute and write x to the power of 3 and y to the power of 3, you can. If you want to write it out 3 times, that works too. This one I'm going to use all of our rules. If I simplify just the top, we're adding our exponents because this is 6 4 times, 1, 2, 3, 4, and this is 6 3 times, so I have a total of 6 7 times. And on the bottom I have 6 5 times. If the 6 is confusing to you, make it an x. It doesn't really matter. What are we doing with these exponents? When we divide, we're really just subtracting. We have 2 extra 6's. There's more on the top, so we have 6 to the power of 2 on the top. If you want to put over 1, you can. You don't have to. If you wrote it out, there would be 1, 2, 3, 4, 5, 6, 7 6's on the top and 5 on the bottom. They would cancel out and leave us with 2 6's on the top. Let's flip over to the back side. This is where it gets a little bit more complicated. Same strategy. I'm going to do it the long way first, and then we'll teach you the shortcut. Same process though. So I'm going to write whatever's in the parentheses 3 times. 4x squared over 5y, 4x squared over 5y, and one more time. So remember, this is all multiplication here and division. So I'm going to just count up how many I have of each letter and number. So on the top, first are 4's. 4 3 times, 4 to the power of 3. Our x's on the top, this is 2 x's here, 2 here, and 2 here, so 2, 4, 6 x's, x to the power of 6. If you wanted to write out x times x times x times x times x times x, you could. On the bottom, we have 5 times 5 times 5. There are 3 5's, don't forget that, and 3 y's, y to the power of 3. Now, if you did this the shortcut way, some people are going to forget the 4 and the 5 and only do the x's and the y's. This is really 4 to the power of 1, 5 to the power of 1, y to the power of 1. So when we have our parentheses, we're multiplying. 3 times 1 is 3. 3 times 2 is 6. 3 times 1 is 3, 5 to the power of 3. And 3 times 1 is 3. We get the same answer. These are exactly the same. Okay? So this one, if you want to go the shortcut way, multiply our exponents. On the top we'll have x to the power of 4. On the bottom we have 4, 2 times 1 is 2. And on the bottom our y's, we would have 2 y's. If you wrote it out 2 times, you'd have x squared over 4y, x squared over 4y, and we'd have 2 x's here and 2 here for 4. and then 2 4s, and 2 y's. All right. This next one's a little bit more complicated. I'm going to write this one out, but if you want to do the shortcut, that's fine. I'm going to ignore this part for just the moment. So I'm going to write this first part 2 times. 3x to the third over 2y. 3x to the third over 2y. Now I'm going to just write this piece, times 1 over x squared. Now this is all multiplication, so you can treat this like one big multiplication and division problem, just like up here. So I'm going to count up how many x's I have first. Not x's, 3's. I have 3 here and a 3 here. That's 3 2 times. I'm going to hold off on the x's because I have x's on the top and the bottom. My 2's, I have 2 2's on the bottom, 2 to the power of 2. My y's, I only have on the bottom 1, 2 y's, so I know there's going to be y's on the bottom. And this 1 we don't really need, because if I take 3 squared times 1, it's still 3 squared. So you can really ignore that. All we have left are our x's, x to the third, and x squared. Now if you look at just the x's, we'd have 3 here and 3 here. So that would be x to the 6th on the top, and we have x to the power of 2 or squared on the bottom. So we're going to have 4 more x's. If we subtract 6 minus 2 is 4 on the top. Or no, 2 of these are going to cancel out with 2 of those, and there'll be 4 left over. So we have x to the power of 4 on the top. That is our answer. If you want to multiply out, 3 times 3 is 9, and 2 times 2 is 4. You can do that. This is the same. If your exponent's 3 or less, I would suggest multiplying it out, but you do not have to. Whoa! Did not realize that this didn't show up. Biggest point on this one, I don't know what all of these say, but anything to the power of 0 is going to be 1. X to the power of 0, 10 to the power of 0, anything to the power of 0. If you have x squared y to the third and a 4 out front, I don't know, to the power of 0, it's going to be